Hello everyone. This video is on the Knewton Alta assignment for section 5.6 called Solving Systems of Linear Inequalities. Alright, so in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Now on the assignment page, you should be seeing the title, the mastery bar, right, that tells you how far along you've gotten, the objectives. Looks like there are 3 objectives in this particular assignment. And then under the current objective, right, there should be a question related to that objective. And under the question, every question, there should be a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. That's for instructors only. But you will have a more instruction button. If you're struggling with a topic or a question, click on this and you'll be taken to a page with some further reading or videos to study. And you'll be given questions related to that instruction. And completing those questions is another way to progress through the assignment. Alright, so the first objective I'm looking at is solve applications of systems of linear inequalities. So hopefully you recall linear inequalities. This is from earlier in, I believe, chapter 4 or 3. One of the earlier chapters. But I have done videos prior to this on, graphing linear inequalities with 2 variables. Remember, you graph the boundary line, you make it solid or dashed, and then you pick a point on either side of the boundary line, check to see if it's a solution, and if the point you pick is a solution, then that side has all the solutions. You shade that side. If the point isn't a solution, well then, the other side of the line is the side you'll shade, the side with all the solutions. So I'm hoping you remember how to graph linear inequalities. I'm assuming you do. We're just going to add another inequality. I kind of do 2 at the same time here, and I'll show you, how to graph a system of linear inequalities in this video. Alright, but first we have an application. So it's just like any other word problem. You read through it, you assign some variables to your unknowns. I'm just going to use x and y for all these, okay? Just remember what x means and what y means. And then you read back through, and using keywords and sentences and whatnot, you're going to translate into mathematics. We're going to translate some statements into inequalities. And then we'll graph those inequalities on the same coordinate plane, right, and try to discover where the solutions of the system of inequalities are. Remember, any solution of a system has to satisfy all the inequalities in the system, or all the equations in the system. But here it's going to be inequalities, okay? Alright, so first I'll read through it. So Jocelyn desires to increase both her protein consumption and caloric intake. She desires to have at least 35 more grams of protein each day, and no more than an additional 200 calories daily. Alright, so 1 ounce of cheddar cheese has 7 grams of protein and 110 calories. 1 ounce of Parmesan cheese has 11 grams of protein and 22 calories. Could she eat 1 ounce of cheddar cheese and 3 ounces of Parmesan cheese is the question, based on her desire. Alright, so what's in question here, the quantities we're going to be dealing with, is the number of ounces of cheddar cheese that she eats. So I'll call that X, okay? Now you can call it C if you want for cheddar and P for Parmesan, but just because we're going to be graphing things on the XY plane, I'm going to try not to confuse it too much and use X and Y every time. Also, we're talking about the number of ounces of Parmesan cheese she could eat. And I'll call the number of ounces of Parmesan cheese Y, right? The variable Y. Now, I'll write up the information we were given on this first example instead of just saying it. Now they say each ounce, right? Each ounce of cheddar has 7 grams of protein and 110 calories. Now, I don't think these numbers are actually true. I think they're just numbers that are popped into the problem. And another piece of information they gave us is that, each ounce of Parmesan cheese has 11 grams of protein and only 22 calories, which is nonsense. There's no way that could happen. But again, I think these numbers are just made up for the problem, just popped in there to help, make you work. Now let's talk about her desires. All right, what her plans are. All right, one of them involves protein intake, and one of them involves calories. So the protein intake, she desires to have at least 35 grams of protein each day, 35 more, right? At least 35 grams from this cheese, right? Now this leads me to an inequality. We talk about the protein, right? So each ounce of cheddar has 7 grams of protein, and each ounce of Parmesan has 11 grams of protein. So we can make like a little protein inequality here. So, if she eats X ounces of cheddar, that would be 7 times X grams of protein. I hope that makes sense, right? Because each of the ounces of cheddar has 7 grams of protein in it. So if she ate, 2 ounces of cheddar, that's 7 times, so there'd be 14 grams of protein there. Add to that the number of grams of protein from Parmesan. Well, she eats Y ounces of Parmesan, and each ounce of Parmesan has 11 grams of protein, so that'd be 11 times Y grams of protein. And she wants this amount of protein she eats to be at least 35 grams. Now remember, at least means greater than or equal to. At least 35 grams. Right, so there's one inequality. Right. Now the next inequality will involve calories. It says she wants no more than an additional 200 calories per day. So no more than 200 calories added in a day. So let's talk about the calories. So there are 110 calories in every ounce of cheddar. There are 22 calories in every ounce of Parmesan. So if she eats X ounces of cheddar, that'd be 110 times X calories she ate. And then if she eats Y ounces of Parmesan, that'd be 22 times Y, right, plus 22 times Y. That's how many calories she would have eaten. And she wants this number of calories to be no more than 200. Now, no more than, not more than means less than or equal to. All right, that's not more than, it's less than or equal to 200 calories. All right, and what we have here is a system of linear inequalities. All right, a system of linear inequalities. And what I'm going to do is I'm going to show you a graph of that system. All right. Now remember how to graph linear inequalities here. All right, and I'll show you a quick picture here. And I'll show you a much better picture, of course, on the Desmos website, the free online graphing calculator, desmos.com. So I'm going to the XY plane here. The first inequality, I'll graph that in like this peachish color. All right. Hopefully you see that color. If not, just hopefully you can follow along. Now, remember, first you graph the boundary line. Now, if x were 0, y would be 35/11ths, which is, almost 3.5. So let's say 3 and then 4 and then, somewhere in here, there's 35/11ths. And if y were 0, x would have to be 5. There's 5, 0. And then, the boundary line would be solid because of the greater than or equal to. And so here's the boundary line for the first one. And then remember, one of these sides has the solutions to that first inequality. Now, just pick a point that's not on the boundary, say 0, 0. Is 0 plus 0 greater than 35, greater than or equal to 35? No. No, it's not. So the side with 0, 0 doesn't have solutions, it's this side. Now, I'm not going to do some shading. I'm just going to do a little arrow to let me know this side, right, the side above this line has all the solutions of the first inequality. All right, then the second inequality, I'll graph the boundary line in this like greenish color. All right, now the second inequality, we have 110x plus 22y equals 200 would be the boundary line, and it'd be solid. Now if x were 0, y would be 200 divided by 22, which would be 100 divided by 11, just a little more than 9. Right, so let's say there's 9 and here's 10 on the y-axis. So there's the y-intercept of the second boundary line between 9 and 10. And then if y were 0, x would be 200 divided by 110, which would be between 1 and 2, right here. And so here's, again, a very, very rough sketch of the solid boundary. It would be a solid one again. All right, and then we got to think of where are the solutions to this inequality, the green inequality. So again, 0, 0 is not on the boundary. Is 0 plus 0 less than 200? Yes. So this side of the green line has the solutions of the second inequality, right? I draw little arrows on the left side of the green line. And then you look for overlap. You look for where the solutions would overlap. Where are the solutions of the first inequality and the second inequality at the same time, right? And that would be these solutions here, right? What's above the beige line and to the left and below the green line, that's this area here. Forever and ever. Now, of course, you wouldn't eat negative ounces of cheese. So really, the only region of possible solutions is this area right here, right? And there are that really, really dark shaded region, and here they are, the solutions of the system. Right? They're the only points that satisfy. I mean, technically, again, all these points out here with the orange shading are also solutions, but they have negative x values, Right? You wouldn't eat negative amounts of cheese. That doesn't make any sense. So that's why I only put in the part there. And you could figure out where the two lines cross, you know, solving a system if you want. You could figure out where they cross here. But then, you know, again, this grayish, this dark area here is this, it contains all the points that satisfy both inequalities, right? And remember that's what a solution of a system was. It's any ordered pair, it's any point that satisfies all the equations or all the inequalities in the system. Now the question was, you know, could she eat 1 ounce of cheddar, so 1 for x, and 3 ounces of Parmesan, 3 for y? I'm going to say no, just based on the look here. The ordered pair 1, 3 doesn't look like it's in this region. Or you could just check the inequalities, right? So that's the big question, right? The question is, could she eat 1 ounce of cheddar and 3 ounces of Parmesan? Basically, you know, is x equals 1, y equals 3, based on my setup, right? X was the number of ounces of Parmesan, cheddar, and y was the ounces of Parmesan. So that's the same question as, is the ordered pair 1, 3 a solution of this system, right? So I plug in 1. Now again, you can look at a graph. Now I'll show you a much better looking picture of this. All right, let's go to that Desmos site. And you can enter inequalities. You know, the two inequalities I had were 7x plus 11y is greater than or equal to 35. Right? And you see that shaded region there in red. Those are all the solutions of the first inequality. And the other inequality was 110x plus 22y is less than or equal to 200. Right, and you see the blue region there. And the region where they overlap, right? You see the region where they overlap? That was the orange region in my picture. Those are the solutions of the system. And then the question was, you know, could she eat 1 ounce of cheddar and 3 ounces of Parmesan? Ooh, it is in the region. So my hand drawing was terrible. You see 1, 3 there? That is in the overlapping region. Right? And you could even see where they meet. They meet at 1.354 and 2.32. That's where the two lines meet. But the 0.13 is in that overlapping region. So it is a solution of the system. So again, my hand drawing was terrible. All right. So the 0.13 is actually in here somewhere. Right. But we'll see that. We'll see it is a solution by actually checking it. Plug in 1 for x and 3 for y, and you'll see that both inequalities are satisfied, right? 7 times 1 plus 11 times 3, is that greater than or equal to 35? Well, yeah, that's 33 plus 7, that's 40 on the left side. Is that greater than or equal to 35? Yes. All right, but that's not enough. Remember, a solution of a system has to satisfy everything in the system. So now since it satisfies the first inequality, now I go to the second one. You know, 110 times 1 plus 22 times 3, is that less than or equal to 200? Well, this would be 110 plus 66. That'd be 176 on the left. Is that less than 200? Yeah. So the answer is yes. Right? It is a solution. So the answer is yes. She can eat 1 ounce of cheddar and 3 ounces of Parmesan, you know, based on the restrictions she set for herself. And that was a lot. I know that was a lot, but that's what you should have. You know, you should be able to do by the time you're done practicing all this and reading all the stuff, all the information from the textbook or the more instruction, practicing problems on your own. You should be able to set up a system of inequalities, 2 inequalities with 2 variables, and look at a graph of that system and say whether a certain ordered pair is a solution or not. You should be able to do that by the time you're done with this assignment. All right, then after you submit an answer, you'll be told if you're correct or incorrect, and then you'll be given some sort of answer explanation. Now they use C and P, I used X and Y, no big deal. And then see, they just plugged in the values and checked, hey, it satisfies both inequalities, so it works, right? They didn't even make a graph. You can make a graph if you want, though. But yeah, so they give you some sort of answer explanation. Please read through the answer explanations, all right, just to make sure you understand why something was right or why something was wrong, and hopefully, after reading through, you can see if you're if you made mistakes and hopefully learn from those mistakes for future questions. All right, so let's move on. All right, so now we're just back. Now it's just simply determine whether an ordered pair is a solution of a system of linear inequalities. So you're given two inequalities with two variables, and you're just asked to see if an ordered pair is satisfying that inequality. So this is plug in the value of x, plug in the value of y, and see if, again, all the inequalities have to be made true. All the inequalities have to be true in order for an ordered pair to be a solution. Or, I'll go to the graph on Desmos. And we can graph these inequalities on Desmos. Now the first inequality is negative 7x minus 4y is greater than or equal to negative 4. All right. Negative 7x minus 4y is greater than or equal to negative 4. All right, so all that area there below the purple line, that purple shaded area, those are the solutions of the first inequality, but not necessarily the second one. Right? Now the second inequality is y is greater than or equal to negative x divided by 4, and then minus 8. Y is greater than or equal to negative x over 4 and minus 8. All right. And let me zoom that out a bit, right? You see that black line showing up. Let me turn the first one off. All right, there's that black region. That's all the solutions of the second inequality. Now if I put the first region back in, look at where they overlap. And that's this area where my cursor's floating around. This is where they overlap, right? This is below the purple line, above the black line, right, where the shading is. See where it's darker than everywhere else? So there's the solutions of the system, this area here. Right, again, below the purple, above the black, the overlapping region. And then they're asking us, is the point 3, negative 5 a solution? So is 3, negative 5, I'll just put the point 3, comma, negative 5, is that in this region? And it looks like it is. All right, there's that red point pop up. See, it's in that overlapping region, definitely. So it is a solution. If it was over here, it wouldn't be. If it was over here, it wouldn't be. If it was in the totally white region, it wouldn't be. All right, but it is in the overlap. It is in that overlapping region. All right, but I'll write this out and we'll check it by hand, of course. You should be able to do all this stuff by hand as well. All right, so back on some paper. So again, the system we're given, we have negative 7x minus 4y is greater than or equal to negative 4, and y is greater than or equal to negative, x divided by 4 minus 8. And then, is the ordered pair 3, negative 5 a solution of the system, right? Does it satisfy both inequalities? So I replace x with 3, y with negative 5, and see if both statements are made true. So in the first inequality, we have negative 7 times 3 minus 4 times negative 5, and is this greater than or equal to negative 4? Again, I don't know this, question mark. Well, this would be negative 21 plus 20, which would be negative 1. And is that greater than or equal to negative 4? Yes, it's greater than negative 4. All right, so good on that, but we're not done. Right? Now, if the answer was no, then I would stop and say, no, it's not a solution of the system. Right? It has to satisfy every single one. All right, then on the second inequality, y is negative 5. Is that greater than or equal to the opposite of 3 divided by 4 minus 8? I don't know, question mark. So negative 5, is that greater than or equal to This is negative 3/4 minus 32/4. Right, 32 divided by 4 would be 8. And putting those together would be negative 35/4, which is definitely to the left of, negative 5. Negative 35/4 is, negative 8 3/4, which is definitely less than negative 5. So negative 5 is greater than negative 8 3/4. Yes, this is true. So since both are true, right, the answer to the whole thing is yes. This point is a solution of the system. And you saw also on the graph that point shows up in the overlapping region. That point shows up in the region with all the other solutions to the system, to both inequalities. All right, so the answer is yes. Great. All right, next. So back to the application deal. All right, now here they're just having you actually just, set up a system first. So instead of x and y, they're using f and p, and they're telling you let f represent the number of bags of fertilizer and p represent the number of bags of peat moss. All right, so here, Jake does not want to spend more than $50 on bags of fertilizer and peat moss for his garden. Fertilizer costs $2 a bag, peat moss costs $5 a bag, and his van can hold at most 20 bags. Set up a system. All right. So again, they gave us letters, so I'll write them again here. So F represents the number of bags of fertilizer. And P, they're telling us, represents the number of bags of peat moss. All right, now the one thing that the last sentence was Jake's van can hold at most 20 bags. So the number of bags of fertilizer plus the number of bags of peat moss is at most, which means less than or equal to. That's at most 20. All right, so that's one equation in the one inequality in the system. And then the other one's about the cost. Right? He doesn't want to spend more than $50. Does not want to spend more than $50. So that means he can spend $50 or less. Now it's $2 a bag for fertilizer. So 2 times F would be the cost of all the fertilizer. $2 a bag for the F bags. Plus, and then it's $5 a bag for the peat moss. So 5 times P would be the cost of all the peat moss. And this must be less than or equal to $50. Right? Because he doesn't want to spend more than $50 in there. There's the system. There's the system. And that would be this one here. Right? 2F plus 5P is less than or equal to 50. That was the costs. And then F plus P must be less than or equal to 20, right? Because his van can hold at most 20 bags. Great. And then I think they'll probably, after I continue here, have us solve the thing, or have us ask if a certain value is a solution. So yeah, so it's all this, and then they add the question: can he buy 15 bags of fertilizer and 4 bags of peat moss? So can F be 15 and P be equal to 4, right? That's the question. Would the ordered pair, FP, if you did ordered pairs F and P like this, would the ordered pair 15, 4, would that be a solution to this particular system? 15 bags of fertilizer, 4 bags of peat moss. All right, so I just plug in 15 for F and 4 for P. So the first inequality, we have 15 plus 4. Is that less than or equal to 20? Absolutely. 19 is less than or equal to 20. Yes. All right, so then I move on to the next inequality. 2 times 15, right? Because if you buy 15 bags of fertilizer for $2 a pop, that's $30. Add to that, 5 bags of peat moss, 5 times 4, that's $20. is this less than or equal to 50? And yeah, 30 plus 20, you have 50 less than or equal to 50. He didn't spend more than $50, so that's okay. So again, the answer is yes to this, right? So far, we've only seen some yeses. Now, you could also check this by, hey, if I called f x and p y, we could go to a graph here. Get rid of this stuff. The inequalities, one was x plus y was less than or equal to 20, and then 2x plus 5y must be less than or equal to 50. And I'll bump this out so we can see the regions. Yeah, and you see where they overlap is in the darker region, right? There's the first one below the blue and below the green. If you put them together, below the blue and below the green is this region here, right? Again, the darkest region, the overlap, is where all the solutions are. And the lines are solid, so points on the lines in this region are also solutions, because this point's going to be on one of those lines. If I put 15 in for x and 4 in for y, you see it's on that green line, which is part of the overlap, right? Again, because the lines are solid. If that was a dashed line, it wouldn't belong. Remember, dashed lines have points that aren't there. So yeah, so that is technically in this overlapping region because the lines are solid. Okay, so once again, yes, that is possible. That is a solution of the system that was written up. Great. All right, now we're asked to actually graph our own. All right, so, and there's a multiple choice region here. All right. Again, the darker region is the overlapping region. All right, so I'll graph these on my own. I'll do it by hand first, and then we'll look at Desmos. Might as well, right, since we've got it available. All right, so the system of inequalities is the following. First one is x plus 4y. Now this time it's just less than, right? Not less than or equal to. So we're going to have a dotted or dashed boundary line here, negative 16. And the other inequality is 2x plus y is just greater than. Again, just greater than. So the boundary line is going to be a dashed or dotted line. Points on the line are not solutions. Alright, so I'm going to make my coordinate plane here. And again, I'm assuming you know how to graph these. So the first one I'll graph in an orangish color. Right. So we'll do the first one in this orangish color and the second one in like a greenish color. All right. Again, whatever color you're seeing. So the first one, the boundary line is x plus 4y equals negative 16. So you'd have 0, negative 4 for the y-intercept. Right, 0, negative 4 for the y-intercept, and then 16, 0 for the x-intercept. Or sorry, negative 16, 0. I think that's 16. So negative 16, 0 for the x-intercept, 0, negative 4 for the y-intercept. And it is a dotted line, a dashed line. Right. So these points are not actually solutions of the first inequality. Right, something like that. All right, and then I pick a point on either side of this dashed line and try the first inequality. Again, 0, 0 is a nice one, especially if it's not on the boundary. Right? Pick any point that's not on the boundary and test it. 0, 0. Is 0 plus 0 less than negative 16? No, 0 is greater than negative 16. So the side with 0, 0 doesn't have solutions. It's this other side. I'll put little arrows there, or we can actually do some light shading. This side has all the solutions of the first inequality only, right? These are not solutions of the system. They're just solutions of the first inequality. And again, this would go on forever this way, all this side. Alright, now the next inequality I'll graph in like a greenish color. Now 0, 1 would be the y-intercept. And then 1/2, 0 would be the x-intercept, right? So very, very close, between 0 and 1 here, there's a half. Again, for another dashed line, right? Another dotted line. Right, like that. Now, you could also figure out where the two lines cross by solving the system, but I'm not going to bother doing that. All right, but you could figure out where the two lines cross by solving a system of equations, right? Replace these with equal signs and then figure out where they cross. But I got this dotted line here, and once again, 0, 0 is not on it. It's on this left side. Is 0 plus 0 greater than 1? No. So the other side, this side, the right side of this line has got the solutions of the second inequality, right? So this, again, some light shading, or just some lines here. They're just indicating that this side has all the solutions of the second inequality. Alright, so where are the solutions of the whole thing? It's where they're overlapping. So this region here that I'm shading in black. Alright, between the two dotted lines. Now the points that are on the dotted lines are not solutions. It's all the points in between the two dotted lines in this region that are solutions, right? So again, you're looking for the overlap. Alright, so which of these looks like this? Let me actually do Desmos too. Alright, let me do Desmos as well, and we'll see the same picture. Alright, so the first inequality was x plus 4y is less than negative 16. Alright, so something like that, right? And the other inequality was 2x plus y is greater than 1. And again, you're seeing, to below the black dotted line, to the right of the red dotted line, and again, the overlap. You can see where the points meet, where the lines meet. But this region down here, right, where they overlap, the darker region, is where all the solutions are. And again, the points on the dotted lines are not in that region. If they were solid lines, they'd be part of the region, but they're dotted. Right? So only the area between the two dotted lines. And then which of these inequalities looks like that? That's this one here, I think. Or this one here. Yeah, 1 1/2 there, negative 4. Two dotted lines, two dotted lines. Yeah, it's this one up here with the two dotted lines, and then I got below the one blue, to the right of the other, the red one, and then the area down there, and then this is the one that matches the two drawings I was looking at. Wonderful. Okay, so again, if you know how to graph one inequality, you should be able to graph the two on the same plane. Right? It shouldn't be that much harder. Just again, you're just looking for that overlapping region if there is one. All right, so this is the same objective. We're given some inequalities here and asked to graph and just point out which one's the graph of the system of inequalities here with the overlap and all that. Alright, so I'll write this out again. Alright, so the two inequalities of the system are y is greater than or equal, so that's kind of a solid boundary line, negative 3x plus 1. And the other one's y is greater than, so it'll have a dotted boundary line, negative 1/2 x minus 2. Alright, now the first one has a y equals negative 3x plus 1 boundary line, so it has a y-intercept of 0, 1, and a slope of negative 3, so I'd go down 3, and then right 1, so 1, negative 2 would be on that. And I'll do it I'll do it in this orangish color. But this one's going to be solid. Nice solid line here. And then which side of the line gets shaded? Well, again, 0, 0 is not on it. If I put in 0 for y, 0 for x, is 0 greater than or equal to 1? No. So it's this side that gets shaded. Right? So this side has all the solutions of the first inequality. Alright, then the second inequality has a y-intercept at -2. Y equals -1/2 x minus 2, and then a slope of -1/2. So I'd go, down 1, right 2. So the point 2, -3 would be on this, and I'll do this in like a greenish color. Now this will have a dotted boundary line. Like that. And then which side of this gets shaded? Well, 0, 0 is not on that boundary line. Is 0 greater than -2? Yes. So the side with 0, 0 on it has all the solutions of the second inequality. So this here. Alright, so there's a pretty big region of overlap. Alright, the overlapping region is, again, the solid line is on it until where they meet. Alright, the point where they meet wouldn't count because it's on a dotted line there. And then you have the dotted line. Those points aren't in the region. Then everything in the overlap. Alright, all this overlapping region where the green and the orange overlap. This is the region of the solutions. Alright, and it goes outward forever like that. Alright, so what graph looks like that? Nope. No, those are both solid boundaries. The wrong one is solid. Looks like this one here. This graph looks like the graph that I had. Wonderful. Alright. Next. Alright, so back to just, here's a linear inequality system. Here's an ordered pair, is it a solution of the system? So this one I'm just going to do out loud. As you just plug in 2 for x and -1/7 for y and see if both these inequalities are satisfied. So 4 times 2 would be 8. 7 times -1/7 would be -1. 8 plus -1 is 7. Is 7 less than 6? No. So this point doesn't even satisfy the first inequality, so it definitely can't be a solution of the system. It satisfies the second inequality, but again, to be a solution of the system has to satisfy every single one. Alright, so another one like this. So again, I'll just speak this out loud. I know there's fractions and stuff, but bear with me here. So 5/4 for x, 5/7 for y. So 5/4 plus, now 8 times 5/7 would be 40/7, which is definitely bigger than 3. So this is bigger than 3 for sure. The first one's satisfied. Alright, and then 3 times 5/4 would be 15/4. 10 times 5/7 would be 50/7. So 15/4 minus 50/7. Is that greater than -4? I believe so, because like 15/4 is 3 3/4, 3.75. And then 50/7. Ooh, you know what? I actually want to write this one out. Sorry, because the first inequality is satisfied. The second inequality I have, again 15/4 minus, and then 10 times 5/7 would be 50/7. Is this greater than or equal to -4? Alright, so let's multiply this one by 7/7, this one by 4/4 to get a common denominator. So that's 70 plus 35, that's 105/28, minus, and then 50 times 4 is 200 over 28. And 105 minus 200 would be negative 95 divided by 28. Now, is this greater than or equal to negative 4? Let's see. 28 times 4 would be 80 plus 32, 112. Yeah, this isn't negative 112. This is good. This works. This is negative 3 point something, which is greater than negative 4. So both are satisfied by that point. Wonderful. All right. All right, then one more like this. So again, this time I'll just write it out straight away. All right, we're plugging in negative 1/5 for x and 2/3 for y and seeing if both inequalities are satisfied. So the inequalities were given: negative 5 times x minus 4 times y. Is that less than negative 1? And 2x minus 7y is greater than or equal to negative 4. And the point we're checking, negative 1/5 for x, 2/3 for y. All right, so in the first equation, if I plug in negative 1/5 times negative 5 would be positive 1. And then 2/3 times negative 4 would be negative 8/3. And is that less than negative 1? Well, this is 3/3 minus 8/3. 3/3 minus 8/3. It's negative 5/3. Is that less than negative 1? Yeah, that's negative 1 and 2/3, which would be to the left of negative 1 on the number line. Alright, so that's satisfied. And the second equation, 2 times negative 1/5 would be negative 2/5. Negative 7 times 2/3 would be negative 14/3. Is this greater than or equal to negative 4? Well, actually, if I do decimals, this would be negative 0.4, and this would be minus 4 and 2/3, 4.6 repeating. Is that greater than negative 4? No. No, it wouldn't be. This would be even further. This would be less than negative 4, not greater than or equal to negative 4, so no on that. Alright, so this does not satisfy the system. It satisfies the first inequality, but not the second one. Alright, so that objective's done, and I think that'll probably be the easiest of the objectives. Alright, just plugging in values and seeing if it works out. Alright, and then back here to solving a system of inequalities by graphing, where I actually graph the system here. So once again, I'll do a drawing with some colors and some lines. So first inequality in the system, negative x plus 2y is less than or equal to 4. Second inequality, negative 2x plus y is less than or equal to 1. I'm just making a very rough sketch here. Now the first inequality, the boundary line, would have 0, 2 as a y-intercept and negative 4, 0 as an x-intercept, and it have a solid boundary line. And the boundary line would be solid, less than or equal to there. And then which side of this has the solutions? Well, 0, 0 would be a solution, so the side with 0, 0 has the solutions to that first inequality. Right? So something like that, below the solid boundary line there. The second boundary line, the second inequality's boundary line, would have 0, 1 as a y-intercept. And if y were 0, x would be negative 1/2. So negative 1/2, 0 there, like something like there for the x-intercept. And also a solid boundary line. So like that. And 0, 0 is on the right side of this, and that would be a solution, right? So the right side of this line as well. All right, and then the overlap would be, now these are both solid lines, so they are both have points that belong to the region, and then the overlap, this region here, would have all the solutions to the system. So something that looks like that drawing. So nope, 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 yes, that one. Great. Alright, and then one more like this. One more like this. So again, I'll draw it out. Alright, so the system we're given here, negative 2x plus y is greater than or equal to negative 4. 2x plus y is less than 2, right? So one boundary line will be solid, the other boundary line will be dashed. In a rough sketch here. Now the first boundary line will have 0, negative 4 as a y-intercept, and negative 2, 0, or just 2, 0, sorry, 2, 0 as an x-intercept. And it'll be a solid boundary line. So like this. And 0, 0 is on this side. That is not that is a solution. 0 is greater than negative 4. That works. So this side of this line has all the solutions of the first inequality. The second inequality would have 0, 2 as a y-intercept for the boundary line, and then 1, 0 for the x-intercept. But it's a dashed line, right? A line where the points on the line are not solutions. All right. So like this. Something like that. And 0, 0 is below this line, and 0 being less than 2, that's true. So this side of this line is, those are the solutions of the second inequality. And then the overlap, contains these points on the solid line until where they meet. And the point where they meet is not a solution because it's on a dotted line, and then the points on this dotted line are not solutions. And then everything in the overlapping region, right, this region here, would be a solution of the inequality. So I'm looking for a picture that looks something like this. So nope. Yes. This looks like my drawing. Just make sure anything else doesn't look any better. No, the one I picked is correct. Alright. Okay, so again, if you know how to draw one linear inequality, you should be able to do these. Just draw another one and then find where the regions overlap. Okay. And then back to, there should just be one more little question here about applications where we set up a system and then, then they ask us, would a certain value be a solution, a certain ordered pair be a solution to the system? Alright, so this one I'm just going to kind of talk out loud. So Mark is increasing his exercise routine by running and walking at least 4 miles each day. So at least 4 miles means 4 miles or more, greater than or equal to 4. So walking distance plus running distance should be greater than or equal to 4. So it's either this fourth option or the first option. His goal is to burn a minimum of 1,500 calories. So minimum means, that many calories or greater. So, and then, 270 calories per mile walking, 650 miles per calories per mile running. So 270W plus 650R should be greater than or equal to 1,500, right? Burn 1,500 calories or more. Walk and run 4 miles or more. That's this last system here. And then they ask a question, would the following be possible? Could he walk 3 miles and run 1 mile? So could I replace W with 3 and R with 1? Yeah, 3 plus 1 is greater than or equal to 4. That works. And then 3 times 270 is 810 plus 650. 810 plus 650 would be 1460. That's not bigger than 1500, so no, this wouldn't match what he wants to do. This would not satisfy the inequalities. Alright, it satisfies the first one, but not the second one. Alright. And that should be it for this preview version of this assignment. And like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same. The structure of the problems should be very similar. So I'm hoping that watching me do all these examples here helps you in some way when you work on the assignment on your own. And thank you very much for watching.